To Unit 8, a little bit of vocab here at the start. So adding and subtracting, and then we bust out with this word polynomials. Okay? A polynomial typically is just going to be multiple terms that are added or subtracted. So like, if you wanted to have an example below there, I mean, it could be just something as simple as, 4x plus 7 or 2x squared minus.
Wait, does multiple terms mean
Multiple terms just means that you're going to have more than one thing going on. So like, I'm not just going to say, hey, 2x. Okay, 2x would be a monomial. It's only one term. Terms typically are separated by adding or subtracting them. So like, for instance, with the two that I put for examples here, this is two terms, 4x and 7, that are being added together. Or here we have 2x squared minus 3x plus 1. I have three different terms that I'm adding and subtracting together. Good question. So, but it's typically, again, it's going to be more than one. If it's a polynomial, it could be a lot. It could be like 6, 7, 8 of them that we're going to run into at times. But that's just a little smaller to be able to get in here.
Like terms are like 4x.
That's right. And so when we get to like terms, thank you. Right, we're going to find terms. Yep. I'm going to take it a little bit deeper than just a like. And I'm going to have to explain this a little bit more as we go too, because there's one exception to this already. When you're looking for like terms, you're looking for things that have the same variable, or if they have the same variable, also the same exponent, or it can just be plain old numbers. So when I'm looking for like terms, we'll kind of get an example going here again. Okay, so let's say I've got a polynomial, a little bit bigger this time. 3x plus 7 minus 5x plus 1, and we want to simplify. We want to do what's called combining like terms. I'm going to go looking for things that, as Aiden was saying before, are the same. So like here, the 3x and the negative 5x are the same. They have the same variable. The number in front, the coefficient is different. But I would go ahead here. 3 minus 5 is negative 2x. And then what are called the constant terms, the numbers that don't even have a variable, they're still like, would be 7 and 1, which would be 8.
Wait.
Yeah.
Why are example 1
Why are example 1 and example 2? I'll explain. I'll explain. They're not exactly the same. There's one slight difference. So when we're doing these, okay, when we're simplifying a polynomial expression, all it is you're going to combine the like terms the same way that we did up in this example. So basically, it's just a little bit of a game that we're playing with, hey, what's alike? Find them. I'm a fan of using signs, so like underlining, circling, boxing them in, using different colors. We have ways that we can do that while we're getting used to it. And so the biggest thing you're going to find when we're simplifying these is being cautious of the signs that are in the middle, because plus or minus are different things. They're going to have different effects on what we're doing. So like Landon was looking at a minute ago, looking at example 1 and 2, they look identical except for one very small difference. Yeah, that symbol in the middle. So here's the deal. If you see a plus there, that plus isn't going to change a sign of anything. So if we wanted to, we could just start combining our like terms right away. So 7x squared and 2x squared is 9x squared. You're like, wait, wouldn't that be like x to the 4th? No. We're just combining terms. We do not mess with exponents when we're doing this. We'll get to that part, but we're not there yet. That's correct. When we get to multiplying with these, and we will, that's when we're going to start doing that. So when I get to my x's, again, different than x squared, they have a different exponent. Watch your signs. Use a calculator if need be. 4 and negative 7, or 4 minus 7, negative 3. And then my last piece, negative 6. I owe my friend $6. I pay my friend 1 back. I now owe 5. Especially at the start, again, people. Colors, symbols, whatever we got to do to find those things that are alike. Now, if you have a set of terms, okay, if you have a set of parentheses, and there's a minus there, that minus goes to every single term inside the parentheses. Every time you see another plus or minus is a new term. And so that minus is going to distribute. So I'm going to take one extra step on this one. I'm going to recopy the first quantity, the first set of parentheses, because there was nothing outside there to mess with it. But here, that minus or that negative is going to change the signs of all of these. So that'll become negative 2x squared. What's negative times negative do? Positive, that's right. And negative times positive is negative. So that's all I'm going to do for the first step, distribute my negative. And now I'm going to do exactly what I did in example 1. Find the x squareds. 7 and negative 2, or 7 minus 2, would be 5x squared. Positive 4x and positive 7x is positive 11x. And if I owe my friend $6 and I borrow another, I owe 7. So just that one little minus symbol completely changed what my simplified expression looked like. So when you're asked in directions for things that we're doing, you may be asked to simplify the polynomial expression. That just means find like terms. Okay? So that's part of what we're getting into. And then we do have to get one application in here today with our new stuff. So, example 3. Find a simplified expression for perimeter. What's perimeter mean? Okay. So perimeter is just when we add up all the sides. So you're like, okay, so,
16.
ooh.
16x plus 1.
Okay, now I have a question. You're right. But here's my question. I'm gonna play devil's advocate here. So I'm sitting here, if I'm just looking at this, and I'm going, okay, so 3x, we're adding up the sides, plus 5x plus 2. If I add those up, that's not 16x plus 4. So what's the deal? What am I not thinking about? Yeah. Even though there's nothing written on this side and on this side, they're still the same length. This is still a rectangle. So if need be, write those other two sides in, or if you just know that, that's cool. And it's just a big combining like terms game. And I know what some of you are thinking already. Hardy, do I have to write all that out? If there's a picture, can't I just combine the like terms? Yeah, I don't care. Make sure you get them all, though. Ooh. Now, see, okay, let me write this. I like what I just heard. Let's chat about this. One way that you can do it is by just adding up all the sides. But I just had it mentioned to me, and I agree with it. If I didn't see those, couldn't I, I'm going to do one of these, couldn't I just combine the like terms for what I see, 8x plus 2, and multiply by 2? You absolutely could. You absolutely could. I love it. Multiple ways to get to the same thing. That is great thought process. Now, am I going to be able to do that with every shape? No. But if it's a rectangle, a square, something like that, can I do that? Absolutely. If it was a pentagon that has equal sides, yes. You'd have to make sure they all had equal sides, though. And there's ways to know that. When we see it, we'll look into that. But yes, that would work. You could just multiply by 5 if you do one side. So that's kind of where we're covering for the start here. We're going to go baby steps. Adding and subtracting here on the first part. So, again, keep this handy. Brand new, we will get into some larger shapes, yes. So today we are going to be dealing with, in the practice packet here, okay, pages 1 and 2. So when we're taking a peek at those, all right, yeah, we'll get everybody set, thank you. Biggest thing to pay attention to, watch the signs in the middle. If they're plus, it's no big thing. But if they're minus, you've got to remember that that minus, no matter where it is going to go through to every term after that and change its sign. Then you can put things together. So hopefully, not too much that's going to mess with it, except a plus or a minus here and there. But you also know me well enough. They're like, uh-oh. I'm going to do some funky stuff. So, let's flip to the back here. So, I think this is going to answer Landon's question a little bit from earlier. So, here on 15, I could have just given you one side of 3x minus 1 since it's a square, and hopefully you'd have figured out the other sides. But if you have, these are both quadrilaterals. 15, they're all the same size. 16, they're not. So that one, I would have to know all 4 sides because I can see from here that they're not all equal in length. But I still can combine like terms as long as I have those sides. The one I wanted to chat through with you, though, here at the back is 17. 17, the way you guys have been rolling, you're probably going to get this without me, but that's okay. The measures of 2 sides of a triangle are given. If the perimeter, they're going to give us what the whole thing is. Find the measure of the third side. So I know the total. I know 2 sides. What am I going to have to do to figure out the mystery side?
What number?
17.
Oh. You figure out.
That you multiply by
Wait, is P the value?
No, P is the perimeter. This is what the whole thing equals if I add up all three sides. Okay. So I can go ahead on this one and say, okay, I have 8x, 4y minus 1y is plus 3y. If I know what the perimeter, if I know what the whole thing is, 10x plus 5y, I can just subtract the parts that I know, and that's going to give me the mystery side. That absolutely would work. So I'm going to leave the perimeter terms alone and distribute my negative over here. And I found my mystery side because now if I go back and I look, 2 plus 3 plus 5x, there's 10x. 2 plus 4 is 6, minus 1 is 5. And I'm set with that. So the other ones on this page 1 and 2, get those set, get those situated. If for some reason you